Welcome back. In this video, we're going to extend our knowledge of solving linear equations and extend beyond just the skill portion to applying this to word problems. So in word problems, we're going to have to create our own linear equation, solve that linear equation, and answer the question. So we're going to begin by reviewing or going through a problem-solving strategy for word problems. And beginning with the obvious, we want you to read and reread the problem. And read the problem with an eye in determining what is the unknown. Many students try and just answer the question right away after reading the problem, and we really aren't looking for you to answer the question, but what we want you to do is determine the unknown and then translate that into an algebraic equation. So read the problem, trying to figure out just what your unknown is. You might want to draw a diagram, especially for geometry type problems, triangles, rectangles, that kind of thing. Then you'll need to choose a variable to represent the unknown and label the unknown. So, X equals the number of widgets sold, okay? Or W equals the width of the rectangle, okay? Y equals the largest even integer. That type of thing. So that's what we're going to want you to do. Then we will want to translate the problem into an equation. So again, you might have to break the problem down, reread it again, break it into phrases, phrase by phrase, and translate those phrases into algebraic expressions, and then eventually get an algebraic equation by connecting those expressions with an equal sign. So make sure you place that equal sign in the appropriate spot. Of course, in word problems, always look for is. Is our key for something's equal to and where the equal sign will go. Okay, so we want to translate the problem eventually into an equation, and we might have to break it down into a couple algebraic expressions first, and then connect those expressions with the equal sign. Then we'll solve the equation using algebra, and then we'll use your solution to answer the question. Now make sure your answer is a logical solution. Sometimes it helps to substitute your answer back in for X. And make sure you confirm that you've answered the question asked. Sometimes we get what X is, but X doesn't always answer our question. We might have to do something with our unknown to finally answer the question. So a couple things to be aware of there. Maybe make notes of that on your sheet, even though I haven't written that down. Those are important concepts to know and understand and realize. Some common mistakes that students make. Students often want to just read the question and jump right to the answer. And rarely in word problems can you answer the question after just reading the problem. What you really want to do is, as I mentioned before, read the problem to determine the unknown and come up with an algebraic equation. That's really what you want to do. Okay? So read word problems not necessarily to find the answer. Let the algebra find the answer. Read word problems to determine the unknown and determine the algebraic equation. That's really why you're reading the problem. You want to get an equation. Then you can let algebra do the work to answer the question. So let's go through some samples. Our first sample says 3 times a number subtracted from 2 is the same as twice the number added to 27. So first thing, let's not try and answer the question. Let's find out what X is, or let's determine what we want X to be. Well, in this case, we're going to let X be the number. And let's see if we can come up with an equation. We might have to do some expressions here. 3 times a number subtracted from 2. Well, if we're taking something away from 2, we're going to start with 2, and we're subtracting 3 times a number. So 3 times a number subtracted from 2 is, well, there's our equal sign. So here we have 3 times a number subtracted from 2 is the same as, well, equals twice the number added to 27. So twice the number added to 27 is 27 plus 2x. So now we've got our equation, and we're set. We can go ahead and solve our equation. So I'm going to go ahead and solve. I'm going to add 3x to both sides. I'm going to subtract 27 from both sides, which leaves me with negative 25 equals 5x. I divide by 5, and I get x equals negative 5. So apparently negative 5 is our number. And can x be negative? Sure it can. Negative numbers are numbers, so that could work for us. Let's check it out. So we have 2 minus 3 times negative 5 has to equal 27 plus 2 times negative 5. That is 2 plus 15 equals 27 minus 10. And sure enough, 17 equals 17, so that checks out. Our number is indeed negative 5. Sample problem 2 says an 18-foot wire is cut so that the longer piece is 5 times longer than the shorter piece. Find the length of each piece. Well, I'm going to draw an 18-foot piece of wire. So this thing is 18 feet. And it's cut so that the longer piece is 5 times longer than the shorter piece. So I've got a long piece and a short piece. And this is 5 times longer than the short piece. Find the length of each piece. So I would determine the variable, write an equation, solve the equation, and answer the question. Well, x apparently is the length of the short piece. In my equation, it's kind of sitting right here in front of me. Don't I know that 5x plus 1x equals 18? So my equation, 5x plus x equals 18, or 6x equals 18. Well, you guys can eyeball this answer. You know that x is equal to 3. Okay? Find the length of each piece. So each piece, the short piece equals 3 feet, and the long piece, which is 5 times greater, is 5 times 3, or 15 feet. And 3 plus 15 is 18, and so that makes up our whole 18 feet. So those answers make sense, and we can move on to sample problem 3. Sample problem 3 says, through 2010, the state of California had 21 more electoral votes than the state of Texas. If their total electoral votes was 89, determine the number of electoral votes for each state. Determine the variable, write an equation in one variable, solve the equation, and answer the question. This one's a little bit tougher, and actually I think this is a problem that might lend itself pretty well to 2 variables. But we've got a total number of electoral votes is 89, so we kind of know that California plus Texas equals 89. And we also know California had 21 more votes than Texas. So that's like C equals Texas's electoral votes plus 21. If I added 21 to Texas, I'd get California's. And, well, I also know California's electoral votes. If I subtract T from both sides, is 89 minus t. So California, I've represented California's electoral votes two ways here. It's 89 minus t and t plus 21. So I bet if I let my variable t equal Texas electoral votes, or the number of Texas electoral votes, I'm going to be able to come up with an equation, because California will equal California, or 89 minus t, that's California's electoral votes, is going to be the same as t plus 21, also California's electoral votes. So I've got one equation out of those two expressions, both in one variable. So now I'm going to go ahead and solve for Texas's electoral votes. So let's go ahead and add t to both sides, subtract 21 from both sides, and I get 89 minus 21 is 68 equals 2t, divided by 2, and 34 equals t. So apparently, we're going to say that Texas has 34 electoral votes, so California must be 34 plus 21, or 55 electoral votes. Okay, determine the number of electoral votes for each state. So 55 for California, 34 for Texas. They do total 89, so that our answer totally makes sense. And we've answered the question, and we can move on. Move on to sample problem number 4. The second angle of a triangle measures twice as large as the first angle. I've got a triangle here, so I've got a geometry problem. So I am going to go ahead and draw a diagram. I'm going to draw a diagram of a triangle. And I'm going to fill it in. And you should do the same thing when you have these kinds of problems as well. So the second angle of a triangle measures twice as large as the first angle. Well, I've got 3 angles here, so let's go ahead. That's my first angle, my second one, my third one. I just arbitrarily picked which one's first, second, and third. It really doesn't matter. But I know the second one measures twice as large as the first. Well, the second one, if that's twice as large as the first, would be 2x, and the first must be x. So x must be their measure of the first angle. Notice I'm breaking this down and I'm just reading it in parts and kind of filling in what I know. I'm not worrying about answering the question. I'm concerned and taking advantage of what I know and putting that in place like pieces of a puzzle. And then things will come together for me. If the third angle measures 40 more than the first angle, well, my first angle was x, so this angle must be x plus 40. Find the measure of all 3 angles. If I look at my diagram, I've got angles of x, 2x, and x plus 40. And of course, I know the sum of all those angles equals 180. So I can simply add those together. X plus 2x plus x plus 40, my 3 angles, has to equal 180. There's my equation. I don't know what the answer to the question is. I can't do this in my head, but I've got an algebraic equation. Let's let algebra do the work for us. So we get 4x plus 40 equals 180. And I think I'm going to stop right there because I bet you can do the rest. I would encourage you to make sure you answer the question. And you can bring those answers when I see you in class.